Hey everyone, welcome back. So in this video we are going to discuss about the design architecture of one of the interesting systems, that is nothing but CricBuzz and Espn Cricinfo. So those who don't know about these platforms, for them I would like to give a brief introduction. So these platforms, or let's say applications, provide you the coverage of cricket matches, live scores, commentary, stats of the player and lot more things. So this is about the application, or let's say platform. Now you can see a diagram on this screen. It seems quite complicated right now, but after watching this video you will have the enough understanding of this diagram and all the tech jargons that are mentioned in this diagram. So let's get started. So again, let's say you're in an interview of system design and an interviewer asked you to design, let's say, CricBuzz. So how are you going to approach this question? So the very first thing that should come into your mind are the functional and non-functional requirements of the system that you are going to build. So in case of CricBuzz, what can be the functional and non-functional requirements? So let's discuss each one by one. So the first functional requirement that we can have is search matches. So this is the first functional requirement that we have. So we just won the final of Champions Trophy against New Zealand. Now let's say I want to see the stats of this match. So there should definitely be the functionality of searching match in our application. Otherwise, how would I able to find the match? So this is about the first functional requirement. The next functional requirement that I can see is get scores from live match. So this should be the most important functionality that our system should provide, because this is the core of our system. We are building such application just to get the real time data from stadium. So getting scores from live matches should be the most important task that our system should provide. So this is about the second functionality that we have. The next functional requirement that we can have is get scores from completed matches. So our system should also provide the stats of the matches that has already been played in the past. Now let's say I want to see the stats of India versus Australia 2023 final match. So our system should be capable of providing the stats of the match that has already been played. So this is about the third functional requirement. Now we are pretty much good with the functional requirements. There can be more functional requirements in this system, but right now I can see these three major functional requirements. So we are good with the functional requirements. Now let's discuss the non-functional requirements of our system. So let's first discuss what actually non-functional requirements are. So non-functional requirements are the requirements that do not affect the flow of the user, but it rather affects the experience of the user. Now what does that mean? So we have two websites, let's say CricBuzz and Espn Cricinfo, and there's a match happening between India and Australia, and you want to see the stats of this match. So you searched India versus Australia in one application, and you searched the same in the other application, that is nothing but Espn Cricinfo. Now let's say CricBuzz provides the detail of that match in 10 seconds and Espn Cricinfo provides the detail of the same match in 100 seconds. So you are definitely go with the CricBuzz because it is providing the match details in less time. So this is one of our non-functional requirement, which we called low latency. Low latency means server should respond to client request in a minimal time. So this is about the first non-functional requirement that we have. The next non-functional requirement that I can see is high availability. So let's say there's a match between India and Australia World Cup final. So in such cases your system really needs to be highly available, because if you will not be highly available, then it is a competitive market. You will lose a huge traffic from your website. So high availability is very important in such applications. The next non-functional requirement that we can have is a strongly consistent. That means whatever changes we made should persist into the database. Now the main purpose of such applications is to provide the real-time data. So this application is famous for real-time data because it is providing update of match ball by ball. So whatever changes we made should be immediately reflected into the database. That's the only purpose of such application. So this is about the third non-functional requirement. But according to CAP theorem, a system cannot be highly available and strongly consistent at the same time. So how we can avoid this constraint of CAP theorem? So for that, we can make few services as highly available and few services as strongly consistent. So this is how we can avoid the constraint of CAP theorem. Services, why? Because here we are considering CricBuzz, or let's say Espn Cricinfo, as a microservice architecture where we will be having multiple services. So by making few services as highly available and few services as strongly consistent, we can easily avoid the constraint of CAP theorem. So this is about the third non-functional requirement. The next non-functional requirement that we can have is scalability. So our system should have the capability of scale up and scale down. Now what does that mean? So let's say there's a match between India and Australia. So in such matches there will be a huge traffic on our application. So according to requirement or according to load, our system should scale up, and according to requirement or load, our system should scale down. So this is about the fourth non-functional requirement. So we are pretty much good with the functional and non-functional requirements. In the next video, we will be discussing about different kind of services that our system can have. Basically, we will translate functional requirements that we discussed into services. So we will translate functional requirements into services. How? We'll see in the next video. So till then, bye-bye. Show some love. Thanks. Hey everyone, welcome back. So in a previous video, we went through with the functional and non-functional requirements of CricBuzz. In this video, we will be discussing about different kind of services that our system can have. Basically, we will translate functional requirements into services. So let's see how we can do this. So the first functional requirement that we had is search matches, through which we can search a particular match, and we can translate this functional requirement into a search service in which user will be searching a match, searching a World Cup, or searching a particular series. So this is about the first service that we can have. The next functional requirement that we had is get scores from live matches. This functional requirement can be translated into a live score service where system will be providing live data of a match. The next functional requirement that we can have is get scores from past matches, that a match that has already been played in the past. So system should also provide the information of such matches. So for that, we will be having another service that is nothing but completed match service. So this is how we can translate functional requirements into services. In the next video, we will be discussing about our first service, that is nothing but search service. So till then, bye-bye, show some love, thanks. Hey everyone, welcome back. So in this video, we are going to discuss about our first service, that is nothing but a search service. So we will be covering everything related to search service, that how we are going to perform a search, what we will be searching, and what database are we going to use for this search service. So let's get started. So the first question is that what we are searching. So the first thing that we can search is a live match. Let's say there's a match happening between India and South Africa. So it might be the case that you will be frequently accessing this data or the update of this match. So this is the first thing that you can search. The next thing that you can search is a past match, or let's say recently happened match, recent match. So India just won the Champions Trophy. So it might be the case that you will be searching India versus New Zealand Champions Trophy finals. So this is the second thing that you can search. The next thing that you can search is a famous match. let's say India versus Australia 2023 finals. So it might be the case that you will be searching some of the famous matches, let's say India versus Sri Lanka 2011 finals, so something like this. Now according to these 3 points, you can identify that user will query the matches based on few keywords. It might be the team names, let's say India versus Australia, India versus New Zealand, India versus South Africa. It might be the player name, or let's say it might be the keywords like India versus Australia series, India versus Australia World Cup final, World Cup semi-final, so something like that. That means your searching will be based on different keywords. Now the question is that where are you going to store this data or metadata of search? So we need some kind of database that will allow us to do fuzzy searching, or let's say wildcard based searching, pattern based searching, because here we have different keywords. So we need a database that will allow us to do searching based on keywords. So for that we will be using Elasticsearch cluster. Now the question is that how this Elasticsearch cluster will get the data. So for that we will be using Kafka queue. Now the question is how this Kafka queue will get the data. So there will be producers on one side of Kafka queue. Let's say this is our Kafka queue. So there will be producers on one side of Kafka queue, and there will be search consumers on the other side of the Kafka queue. So whenever a new match will be played, these producers will create a new topic, or let's say payload, for this match, and this payload will be sent to this Kafka queue. On the other side of the Kafka queue there will be search consumers. So these search consumers will listen to those topics, and then these search consumers will send those topics to Elasticsearch cluster. So this is how Elasticsearch cluster will get the data. In the next video we will be discussing about the most important service of our system, that is nothing but live score service. So this is all for this video. Hey everyone, welcome back. So in a previous video we discussed about search service of our system. In this video we are going to discuss about the most important service of our system, or we can say the core of our system, that is nothing but the live score service. But let's first see what this live score service does. So this live score service provides you the detail of a live match that is happening. But the question is, which live match? Obviously a match that we searched using a search service. That means this live score service depends on the search service. But the question is, should it depend on the search service or not? Actually it can depend, but this will become a strict dependency on search service. And I really don't want this, because here I'm considering CricBuzz as microservice architecture where each service will be independent from each other. So I want each service to be loosely coupled. So let's see how we can achieve this. So here we have two services, search service and live score service, and here we have this user, and I want all the services to be loosely coupled. So let's say there's a match happening between India and Australia. So user will make a request and simply write India versus Australia in the app, and there will be get queries. You can see these get queries or search queries for search service. In return, this search service will send the match ID of this match, India versus Australia match. Let's say the match ID of this match is M12. Now this live score service will be managing the live score or stats of lot of live matches. So we here from front end we will send this match ID, that is nothing but M12, into the live score service, and in live score service we will match this match ID that was sent by search service and a match ID that is present in live score service. So we will match both the match IDs. If match ID will be matched, then we will send the stats or match data to the user. So this is how we can avoid the strict dependency, and we can make our system loosely coupled. Now the next question is that how this live score service will get the data, live data for a particular match. So let's say there's a match happening between India and Australia. So how this live score service will get the live data for this match? So it is obvious that this live score service is not going to generate the data. it must be using some external APIs for fetching details, live details for this match. So these API providers can be a Rapid API, or it can be the official APIs of Cricket Board. So something like that. These APIs provide live match updates ball by ball. So we have decided that match data will be provided by the external APIs. We will make API calls in every second, and that will come up with the match details. Basically, we will pool to their server. So let's try to understand this with the help of example. So let's say here we have this live score service, and here we have a server located in the stadium. So this server is responsible for providing the live match updates for us. So we will make from live score service, we will make an API call using external API, and then this server will return the match details to us for every ball. So this is how using external APIs we can get live match updates. Basically we are polling to their server in every second. Now let's say no one is watching the match, or we can say that matches is stopped due to some issue. It can be a weather issue or a bad light issue. So matches is stopped now, but you're still making API calls. You are just wasting your resources. Even if there's no update from the match, no ball is bowled, nothing happened, but you are still making an API call. So basically you are wasting a resource. So polling to the server is obviously not a good choice. So what else we can do? So we have one more option, that is nothing but webhooks. Webhooks are also similar to APIs. We can push updates via webhooks. That means we are going to use push model now instead of a pull model. Now these webhooks also send response to the application, but there will be no request. These webhooks are similar to callbacks. Now what this callback means? So callbacks are the function that gets executed whenever an event occurs. Now let's say if you are making a payment and payment gets successful, so this is an event, so this callback will get executed. So this is about the callbacks. Webhooks are also similar to this. So let's try to understand how we can push updates via webhooks to this live score service. So here we have this live score service. This is nothing but our live score service, and here we have the server that is located in the stadium that provides us the detail of live match ball by ball. So whenever a new event happens, this event can be anything, let's say a boundary or six or a wicket. So whenever a new event happens, this webhook pushes this information, or let's say update, to this live score service. So whenever a new event happens, this live score service gets the update instantly. So this is how a live score service will get the data. Now, do we need something for caching? Let's say there's a match happening between India and Pakistan, which is a very frequently accessed match. So for such matches, we can put that data into the Redis cluster, and whenever this live score service will receive a new event, or let's say will receive a new update, this live score service will update the data, or let's say publish the data into the Redis cluster. So this is how we can use Redis cluster for faster retrieval. So here we have this live score service, and here we have this Redis cluster. So whenever this live score service will receive any update, this will instantly send this update, or let's say publish that update to the Redis cluster. So this is how we can reduce the latency of our server. Now the match data is in Redis cluster. So how are you going to send this data to different users? Are you going to tell them to poll the server and ask for match update at every second? But we have seen that polling is obviously not a good choice. So what else we can do? Now we will be using something like WebSocket servers. So we will be having WebSocket servers that will make an open communication with the users. So this WebSocket server will subscribe to this Redis cluster. That means here we are using publisher subscriber model. WebSocket server subscribes to this Redis cluster, and whenever a new update receives, this WebSocket server sends this update to all the users, or let's say broadcast this update to all the required users who asked for the match details. So this is all about the live score service. In the next video, we will be discussing about the last service of our system, that is nothing but the completed match service. So till then, bye bye, show some love, thanks. Hey everyone, welcome back. So in this video, we are going to discuss about the last service of our system, that is nothing but the completed match service. This service provides us the detail of completed match, or let's say stats of the match that has already been played. Now the question is, which match? Obviously a match that we searched using a search service. So here we are going to use the same logic that we used in the live score service for loosely coupling. Now first we will perform a search using search service. Then this search service will send the match ID, and then we will send this match ID to the completed match service for further searching. Now the question is, where are we going to store this completed match data? So when you go to the official website of CricBuzz and search for 1975 World Cup, so you will get the data for that World Cup as well. Now you can identify that they are storing data for almost each and every match. Even if it is national match or international match, they are storing data. So for this service, we need a database that stores huge amount or huge volume of data. Something like Cassandra, which is a NoSQL database. So for this service, we are going to use Cassandra, which is a NoSQL database. Now the question is, how we are going to store this data to Cassandra, because we are getting this data from external APIs, or let's say webhooks. So how we are going to store this data into Cassandra? So let's try to understand this with the help of example. So here we have this live score service that listens to those webhook events, and here we have this server that is located in the stadium. So this server provides us the detail of match at every ball, and here we have this completed match service, and here we have this NoSQL database that is nothing but Cassandra, and that is going to store the data for completed match. So there are third-party APIs available that provides the summary of a match after match end. In the server, whenever a new event occurs, this update goes to live score service. So in this webhook, there will be an event which is called complete match. There will be complete match event. So this event, when this event will occur, this data will go to the live score service. This live score service will store this data or complete match data into Cassandra. So this is how we can store the complete match data into Cassandra. So this is all for this video. Now I hope you will be able to understand this diagram and the tech jargons that are mentioned here. So this is all for this video. In next videos, we will be discussing few more interesting systems. So till then, bye bye, show some love, thanks.